Hi guys, today we're going to be reviewing combining like terms. So basically for today, we're going to give you different expressions with lots of different terms in there. And our goal is going to be to simplify those expressions down to as few terms as we can by putting together the like terms. Okay. So we have some examples at the top. Again, as we're going through this, you got a couple options. We linked this PDF on your Google Classroom page, so you can open it and write on your screen using your stylus, having this video up as half of it and your notes as the other half. You can print these notes and write directly on there, or if you want to have a scratch sheet of paper out where you're just writing down each of the examples, that works too. Okay, so example one here gives us an example of two terms that we would consider like terms. Okay, they're like terms because if we look, they have all the same pieces. Okay, so like here, we have an x attached to our 8. We also have an x attached to the 3. The fact that both of them have the same exponent on there and it's the same variable makes them like terms. Here it's not written, but really we have an unwritten exponent of a 1 on both of those, right? So when we add together like terms, our coefficients, our numbers in front, are going to be put together. Okay, so here if it's addition, we would add them. If it was multiplication, we'd multiply them. If it was subtraction, we'd subtract them. So 8 plus 3 would make 11. And then we're not going to add these exponents. Okay, we're going to keep our exponent the same. If we're just combining those, it would make 11x, not 11x squared. Okay. So that's the basic gist of it. So a lot of today is matching up our parts that go together. So for example, if we looked at 2, personally, we like to look through the whole thing and just kind of identify what our different exponents are as we're going. So we have an exponent of a 2, no y at all attached to it, a 2, and then a y to the third. Okay. So if we were looking for like terms and we were trying to match up what goes with this 2y squared, well, 7y squared has a y squared, as well as this minus y squared. And notice that minus sign is really attached. This is really like saying a negative 1y squared. If we were going to put all those together, 2y squared plus 7y squared, well, that would be 9y squared. And then we'd subtract 1y squared. So we'd be down to 8y squared. Then we still have this plus 2, and notice that doesn't have any terms that it matches with. So it would still just be plus 2. And then same deal with this plus 3y to the third. And if you're thinking, why can't I combine the 3y to the third with the 8y squared? It's because one of them is a y squared and one of them is a y to the third. They aren't like terms. Something we want you guys to get in the habit of, we wouldn't take off for this, but in general, in math, we usually write this in standard form with the biggest exponent being first. Okay, so if it was in standard form, it would say 3y to the third plus 8y squared plus 2, where the exponents are in descending order, the biggest down to no exponent at the end. Okay, but if you just wrote your answer as what you have in red there, we would give you 100% on that problem. Okay. If we look at 3, we want to match up our like terms. So we have an 8m, and we'd look through and see, do we have any like terms? So it looks like our only like term is this negative 3m. So we put those together, 8m minus 3m, that's 5m. Then we keep going. Well, we have a negative m squared. Well, that would match with the plus 4m squared. So negative 1m squared plus 4m squared, that'd make a plus 3m squared, because negative 1 plus 4 is 3. Then lastly, we have a negative 9 and a plus 5. Those together make a minus 4. Okay. And if we're going to write this in descending order, we'd put the 3m squared first plus 5m minus 4. Okay. Look at 4. Notice now we have multiple different variables, right? We have a's and b's. Okay, so they need to match perfectly to be like terms. They need the same exponent and they need the same variable. Okay, so if we looked at 4, we have a 3a to start with. We're looking for a like term. The only like term with that would be the minus 2a. Okay, so 3a minus 2a, that makes 1a, or just a. Then we keep going. We have a negative 2b. Well, the only like term with that is the negative 5b. Notice that minus sign in front is attached to it. So negative 2b minus 5b, that makes minus 7b, because negative 2 minus 5 is negative 7. Okay. Then we have our positive 6 and our negative 11. Those go together. 6 minus 11 minus 5. Okay. And that can be our final answer. Okay, we don't have any exponents where we would have to rewrite this. Okay, so it would just be like that. Try another one. So 4y to the third, we want to look for any like terms with that. Well, the only other y to the third we have is this minus 9y to the third. So 4y to the third minus 9y to the third would be negative 5y third. Keep going. We have a negative 7y squared. Well, that would match with the plus 5y squared. Negative 7 plus 5 minus 2y squared. And we keep going. We have a plus 2. That matches with the plus 7. 2 plus 7 plus 9. Okay. Last one here. We have some m's and n's. Okay, so again, we look for the like terms. 7m, well, that would match with the plus m. So 7m plus, this is really a 1m, that make 8m. Keep going. Negative 2, well, that match with the negative 8. Negative 2 minus 8 minus 10. Lastly, we have 4n. Oops, color. 4n. Come on. Green. There we go. And a negative 6n. 4n minus 6n minus 2n. Okay. That's the basic gist of it. Okay, why don't you guys get some practice in with these? Okay, so on a separate sheet, let's try to work through 1 through 4, and then from there we'll check our answer. Okay, let's see how we did. Okay, so we combine these. These are going to be our answers for this one. We have 15a plus 19. Number 2, should have got 10n plus 1. Number 3, we should have got negative 5x squared. Then minus 5x. Then minus 10. Then 4, we should have got negative 2x to the third minus 8x minus 9. Okay. Couple more. Why don't you guys try doing these on your own, and then we'll check and see how we did. Okay, let's see how we did. We got negative 9x to the third that didn't have any like terms. Then we combine the negative 2x squared and the negative 3x squared to be minus 5x squared. 4x and negative 14x minus 10x. And then we have a plus 12 and a plus 8 plus 20. Okay, that would be our final answer. Try another one. Okay, so we should have combined 19x to the third and negative 13x to the third. So that'd be 6x to the third. That plus 5x squared doesn't have any like terms, so it's still there. Negative 7x plus 9x, that'd be plus 2x. And lastly, negative 4 and negative 5 together make minus 9. Last two. 7, we have some x's and y's. Okay, so 4x squared would combine with 2x squared to make 6x squared. 5y squared would combine with y squared, make plus 6y squared. Negative 3x would combine with 5x, make plus 2x. And then we just have that plus 3 hanging out at the end. Last one, 8x squared combines with negative 3x squared to make 5x squared. 2x minus 5x minus 3x. And negative 14 plus 5 minus 9. Okay. This is one of those building block skills you'll see used in future lessons, so we want to make sure we master this first. Okay, so for example, tomorrow we'll get into distributing and combining like terms, where this individual step will be one step within bigger problems going from here. Okay, so that wraps up our lesson for today, and we'll go from there.